In this video, we're going to look at how to draw Lewis structures for organic compounds. But to start, I'm going to do a quick refresher on drawing Lewis structures for inorganic compounds, which is what we did in general chemistry. Now, the rules that we used for drawing Lewis structures for inorganic compounds will work for organic compounds, but as we're going to see, there are ways that we can make doing it for organic compounds easier and faster, which is important because oftentimes these organic molecules are huge, and so if we tried to use the set of rules that we use for inorganic compounds, it would take forever to draw the Lewis structures. All right, and I'm going to go through this example kind of quickly. If you want more examples, you can go back and I have other videos that I made for my Gen Chem classes that are a little bit slower and do more examples. So the first thing we need to do is decide what is the central atom. Because carbon is to the left of oxygen on the periodic table, it is less electronegative, and it's probably going to be my central atom. So my arrangement of atoms is going to be with carbon in the center. The next thing I need to do is I need to decide how many electrons we have, and specifically I'm interested in valence electrons. So based on their positions in the periodic tables, I know that carbon has 4 valence electrons, oxygen has 6, there's 2 oxygens, so I'll do 2 times 6, so I have 16 valence electrons that I need to distribute in my Lewis structure. So I usually start by forming single bonds between all the connected atoms, so I'll give a single bond between the carbons and oxygens, and then I assign the remaining electrons to first the external atoms, give each one an octet, and then if I have anything left, then I can move on to the central atom and give it an octet. So I have 16 electrons to give out. Each bond is 2, so I've already given out 4 electrons. So I've given out 2, 4, here's 6, 8, 10. Now that oxygen's full. 12, 14, 16. That oxygen is full, and I've given out my 16, so I don't have any more, so I have to stop. And so now we check and see if any of the atoms don't have a complete octet. If they don't, then I need to change one of my lone pairs into a bonding pair. And so I can see carbon only has 4 electrons in this Lewis structure. It needs 8 to have a complete octet, so I'm going to take a lone pair from each of the oxygens and turn them into double bonds. And so now carbon has its complete octet. All right, so when we draw Lewis structures for organic molecules, they're still going to look the same. We still want to make give everybody a complete octet, but we're generally dealing with a smaller set of possible atoms. And in general, right, we're going to be working with carbon, hydrogen, oxygen, nitrogen, and halogens. Now, we can certainly use the rules that I just did for carbon dioxide for organic molecules, but the organic molecules are often huge, and it would take forever to do Lewis structures in that way. So what we can take advantage of is in organic compounds, the few elements that we're going to be dealing with often have very predictable bonding arrangements, and they are shown down at the bottom. As long as the atoms are neutral, these rules tend to be true. Carbon basically always forms 4 bonds. That's something that we need to sear into your head for organic chemistry. Carbon likes to form 4 bonds. Nitrogen likes to form 3 bonds and have 1 lone pair. Oxygen likes to have 2 bonds and 2 lone pairs. And then both hydrogen and halogens like to form 1 bond. Hydrogen doesn't have any lone pairs, and the halogens will have 3 lone pairs. All right, so if we use these rules for organic compounds, it makes drawing the Lewis structures much faster. And generally, the carbons form chains in these organic compounds. And so I'm going to have my 2 carbons together. And I know each carbon wants 4 bonds, so I can even go ahead and put the 4 bonds on each carbon. And hydrogen likes to form 1 bond. Right? I have 6 hydrogens, so if I go and fill in the hydrogens, that would be it. That's our Lewis structure for C2H6 or ethane. And so you can see, because I know how many bonds carbon and hydrogen want to form, it makes drawing the Lewis structures much faster. All right, in this case, we've got C2H4. So I've got my carbons. I know they want 4 bonds. Right, now I have 4 hydrogens to give out. Right, now I'm stuck a little bit. Right, carbon wants 4 bonds, but I only have 4 hydrogens. Right, there are 2, carbon is missing a bond in each one. And so what we would do in this case is say, oh, well, rather than forming all single bonds, if I don't have enough hydrogens, we'll form a double bond. And now I've got C2H4, all my carbons have 1 bond. I'm sorry, all the hydrogens have 1 bond, and the carbon has 2 bonds. Very often what people will do in organic chemistry, because once I get to these bigger molecules, there are lots of possible ways that I could connect all of these atoms together. And that's something we'll talk about more in chapter 1 and then even more in chapter 2, and that is we can have isomers. So that's compounds with the same number and types of atoms, but they're connected differently. So very often what people will do is they'll write the formulas in such a way that it tells you how things are connected. And these are often called the condensed formulas. And so it's saying that we have a CH3 connected to a CH2, connected to CH2, and then there's an OH on that. And so if we wanted to draw the Lewis structure, I would have my 3 carbons, and then an OH, and there's 3 hydrogens on the first carbon, it's a CH3. And then it has a CH2, so there's 2 hydrogens on that. And then there's 2 hydrogens in addition to the OH on the third carbon. All right, I've got one more example involving isomers. All right, so in this case, we're told that there are 4 constitutional isomers of C3H9N. And they want us to draw a Lewis structure for each one. So what I would probably do, because I know carbon likes to form chains, is I'd start off by saying, all right, let's put the 3 carbons in a chain. And then I'll just put the nitrogen on the end. Now I know carbon likes to form 4 bonds. Nitrogen likes to form 3 bonds and have a lone pair. So I'll go ahead and give nitrogen its lone pair. I'll give it 2 bonds. Right, each carbon needs 4, so I'll go ahead and put the bonds in. And then we'll see if I have enough hydrogens to fill it out. Right, so I'd need 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So I don't need any double bonds in this case. I can get away with all single bonds. Okay, so that's one of our constitutional isomers. And again, constitutional isomer, that means that I have the same number and types of atoms, but they're connected in different ways. So I want to draw a Lewis structure that has 3 carbons, 9 hydrogens, and 1 nitrogen, but that they're connected differently than they are in this structure. And so if I number my atoms, my carbon atoms, as 1, 2, 3, right now nitrogen is on the end. It's on carbon 1. If I was to connect that nitrogen to carbon 2, that would be a different molecule. It would be an isomer of the first one that I drew. So if I was to do that, I'll have a different molecule. And nitrogen wants a lone pair and 3 bonds, right? It's got the 1 to the carbon. It'll have 2 more to hydrogens. Each carbon has 4 bonds. Now if I put in my hydrogens, 3, 4, 5, 6, 7, 8, 9. So I think we have a second isomer for C3H9N. Now it might be tempting to put the nitrogen on carbon 3, but that's just this isomer flipped around, right? It doesn't, I could just renumber these as carbons 1, 2, and 3, and so that would actually be the same molecule. So that wouldn't be a different isomer. But rather than having the 3 carbons in a chain, what I can do is insert the nitrogen into that carbon chain. And so I can do right? And then nitrogen wants a lone pair and 3 bonds. It's already got 2 bonds to the carbon, so it'll need 1 hydrogen. This carbon needs 3 more bonds. This one needs 2 more bonds. 3 more bonds. Right, double check. We'll make sure I didn't give out too many hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and then to get our last structural isomer, what we can do is rather than having these 2 carbons connected, I can go and have nitrogen connected to 3 carbons. Right, nitrogen wants 3 bonds in a lone pair. It's got 3 bonds, so I think we can just give them a lone pair, and then each carbon needs 3 more bonds. 3 times 3, that'll take care of my 9 hydrogens. All right, and so now we have the 4 constitutional isomers with the molecular formula C3H9N.